I'm going to talk about Bitcoin, and I think you'll all hope I'm going to talk about it. But first I'm going to talk a bit about value in general, not particularly in Bitcoin. Because what is value? Well, this is value to me. A nice steak on a barbecue, or going on a holiday in Croatia, or having a nice day with some friends. And this is value to me. It's a drama. Oh, by the way, that's me. My name is Mark van Cuijk. I'm since this week full-time employed for a Bitcoin startup. What we're going to create in Europe is a Bitcoin exchange. I've been involved with Bitcoin now since about 2 years, and it won't let me go. So, well, this is value to me too. Not because it's interesting, I can put it on fire and there's not much heat off from it, so it's not for that reason. But I can give it to someone else, and that person can give something in return that I like. This is value to me too. There's nothing to do with money, but it's for freedom, and it's something I like. Or WordPress allowing people to publish their ideas. Firefox in the other way. So all kinds of things have value, and it doesn't need to be money. Well, this has value to me too, and it's money. Now, there are three main things you can do with money. One is a medium of exchange. Now let's see, I have a chicken. But well, I don't need my chicken, this is where I live, so I want it fixed, but I don't know how to do this. So what can I do? Well, I can give someone my chicken, and I hope I get something in return, and give this to someone else to fix my home. And then everybody is happy in the end. And money is also a store of value. Let's say I want to buy this house, and this house is quite expensive. Before I saw this house, I didn't even know there are branded houses, but this is a brand. So I do some coding, and I get some money, and I do some more coding, and I get some money. And I do some more coding and I put it away, and eventually I might be able to buy that house. The third thing is that money is also a unit of account. So let's see, I'm doing 3 coding sessions. How does it compare to a stack of pancakes? Is it more or is it less? So when we express the value of a coding session in euros and we express the value of pancakes in euros, we can make a comparison. So therefore, money is also a unit of account. Now, what are monies? Well, one example is the United States dollar. Right now it is still money. Some people believe it's going to collapse soon, but we'll have to wait for that. The Chinese have their own money, but you can also use gold coins as money. One such gold coin is approximately 950 euros at the moment. And actually, there are a lot of things you can use as money, as long as it has a couple of properties. And there are 6 main properties you want of money. One of them is that it's portable. When you use, for example, speakers as money, that's difficult. You need to carry them and trade them. It's not easy to do. You want it to be divisible. You see, when I have a gold coin worth 950 euros and I want to buy a bread, well, someone has to give in. Therefore, it's better to have it divisible. You want it to be durable. For example, if you're using shells as money and you put them in your pocket, they can break or they can tear, and well, that's not what you want. And very important, you want it to be sufficiently rare. If somebody can create money out of thin air, then somebody can become rich without doing something, and that will devaluate the money and it's useless. I want it to be fungible. For example, if I have a €5 bill, my €5 bill is accepted in the same way as some other €5 bill. Well, maybe the new €5 bill is not accepted by some machines, but that's another problem. It should be replaceable, fungible. And non-consumable. Using apples as money is, they're not durable, by the way, apples, but they're also not consumable. You eat them and then your money is gone. So this is not something you want. Now, Bitcoin is a new kind of money, and it's a digital kind of money. Who of you have already used Bitcoin? Okay, 2 people. Great, then this is really an introduction. Okay, in the core you have a Bitcoin address, and a Bitcoin address is something like a bank account number. It's a unique string of letters and digits like this. And when you want to spend, you can put money into such an address and you can then spend it. Now, when you want to spend it, you create a transaction like this. You say, I want to spend, transfer, say, 2.5 Bitcoin from this address to this address. Now, then what you do is you create a digital signature and you put it below the transaction, and that way everybody can verify that the transaction is okay. Now, let's see how that works. You publish the transaction and it's public in the network, everybody can see it. In fact, there's a website, blockchain.info, this is a screenshot from there, and you can see every transaction that has happened in the past. For example, here in the top, you can see a transaction which sends a couple of Bitcoins from this address to these two addresses, 7.5 Bitcoin to the top address and 50 Bitcoin to the second address. Well, as I said, you put a digital signature with the transaction to allow everybody to verify the address, the transaction. But if you want to create a digital signature, you need a key pair. You need a public and a private key. You need your private key to create a signature, and you need the public key to verify it. Well, the private key you keep to yourself. Your public key, you hash it, and then you encode it with base 58. The details are not really important. But what you get then is a Bitcoin address. So this results in, as long as you know someone's Bitcoin address and you create a transaction, you can know that this is a transaction for that address because the public key is in there. Now that person wants to spend the money, it needs the private key corresponding to the same public key, and only that person knows the private key and can spend the money. Is this clear to everybody? If there are questions, it's okay to ask them. Okay, cool. Now, well, let's see a couple of addresses. To who can an address belong? Well, this is my address, one of my addresses. What I've done is I've told my computer to start generating addresses, key pairs, and keep generating them until one is found with the prefix 1fatny, because that's my nickname and I thought it was cool. It took me 3 quarters, by the way. But when you send some Bitcoins to this address, I can spend them with my private key. Another address is this one, and it belongs to WikiLeaks. And you can send donations to it. Now, one thing I said earlier is that the information is public, all transactions. Well, yes, that means you can look up what amount of Bitcoin they have received. And in fact, this is a screenshot from December last year. They received about 3,500 Bitcoins. They spent 2,500, so the final balance is 1,000 Bitcoins, approximately. But another thing you can do is create an address for each individual transaction. Now, I have this address I showed you, and it's public, so everybody can see how much there is on that address. I may not like that. When you compare it to the current banking system, everybody has 1 or maybe 2 bank account numbers, but you cannot see the balance of an individual bank account, so that takes care of a little privacy. In Bitcoin, the address is public and the transactions are public, so you can see the balance. But you don't need to make public what addresses belong to who. The address I showed you is one I've published, but I have a lot more addresses. Actually, let's say you want to send me some Bitcoin, I can create a key pair, so I have a new address which I give to you, which is never used, and I can spend the Bitcoin, but you cannot see any other addresses that belong to me, so you still don't know how much Bitcoin I have. Why do you want this? Privacy. Another thing is that you can use it for online payments. Let's say I'm Amazon and I want to receive Bitcoin payments for selling books. What I can do is when someone is in the checkout flow, I create a new address specifically for this person, for this transaction. And when any payment is received on this address, I know it belongs to this invoice, to this payment. Now, let's look at something that is quite a problem in this setup. Let's see, someone with the address 1JGDE whatever, creates a transaction sending 2.5 Bitcoin to me and sending 2.5 Bitcoin, the same 2.5 Bitcoin to the SIGINT address. Now, you can create a signature for both of them. So who gets the money? This is called double spending, and Bitcoin has a solution to this. What you do is you broadcast a transaction onto a peer-to-peer network, and people that receive your transaction broadcast it again. But there can be nodes that receive both transactions in the network. Now, what they do is quite an easy rule. The first transaction wins. So if I first get the transaction that I get my money, I'm happy, I have my money. If then someone says me, well, no, SIGINT gets the money, I say, well, no, the first transaction wins. But someone else has another opinion. So now we have two different opinions, and then the question is, what is the truth? Therefore, we have the blockchain. And the blockchain is a data structure which changes blocks, and the blocks, one block contains some header fields and a list of transactions that are anchored in history. You can see some information about the random block I found on the internet. Okay, in the block you see a set of transactions. The first transaction is always different. I'm going to say a little bit about that in a minute. But you can see here there is transactions, some money comes in, money goes out to two addresses, and you can create this list of transactions. Now, people who create this receive transactions from the network, they keep them in memory, and they're going to find the block. They compute a hash over the block, and they're going to look if this hash is smaller than a certain value. And this is what is called mining, and some people may have heard about it. Now, what you do, you receive a set of transactions. You fill in the header fields, and in the header is one field, it's called a nonce. It contains a random number and it has no meaning. You just put in a number, then you compute a hash, and you look at the hash and you say, well, is it below a certain threshold, a certain target? And if it's not, then the block is not valid, and you try another nonce, another random number. You do the computation again, the hashing, and you come to another hash, and you say, well, it's not okay, well, and you keep repeating it until you find one which is below a certain target. So what you're actually doing is brute forcing a certain hash. This may be a difficult part, so if there are any questions, it's good to ask them now. Or is this clear to everybody? Okay, that's a good question. Why are we doing it this way? Let's see, I've already skipped over this. Okay, why we're doing this is, let's say one person, I receive a transaction and I think I receive Bitcoin, but someone else receives another transaction and therefore ignores the transaction that the money comes to me. What we're doing now is we're going to create blocks, and as soon as a block is created, the transaction that node has in memory is included in the block, and then someone else with another transaction which collides dismisses this transaction. So at first you say, okay, the first transaction wins, but as soon as someone creates a block and it contains a different transaction, then that transaction wins. So what this process does is when there are two competing transactions, somebody has double spend, then it decides in a consensus way in the peer-to-peer network which of the two transactions is true and which of the transactions will be discarded. Okay? So now we have a new rule. It says the longest chain wins. So at first, if you receive a transaction, you keep it in memory. If you receive another transaction and it collides with the first transaction, you discard it, you ignore it. But as soon as you receive a block, you accept all the transactions in that block, and if they collide with something you have in memory, you discard those. But you can receive two blocks. It can be coincidence or on purpose that two blocks have been found at the same time with different transactions. So still there can be two histories. But a block is always referring to a previous block, so you get a chain. And when you get a fork, because this happens, and there will always be one of the two that will be faster because they're A, because there's luck, or B, because there's more processing power finding hashes on that block, on that chain. So if I have a transaction with a block and there is a fork, but that other chain is longer and I receive it, then I discard all blocks in my chain and I accept the other chain for the truth. Well, this is something interesting because that means I can think I have received money, but I can lose it in the future. This is something that's unique to Bitcoin, and you need a way to handle it. Now, let's say I'm a website and you can download MP3 files, and they cost you like €1. If I receive €1, a transaction with the Bitcoin equivalent of €1, I say, okay, you can download the file. And if it has been double spent because of fraud, well, I haven't really lost anything because it was a digital file anyway. I just lost my revenue and it's only €1, so it's something I can risk. Now, let's say I'm selling a book of €40 and I say, okay, this is a little bit more value to me. I want to be a bit more certain. What you can do is you can wait until the transaction appears in a block. So as soon as that happens, you're not 100% sure still, but for a person to double spend his Bitcoins and make sure that it gets into a block, which is not the same block as which will eventually win, it's really difficult to do. So I can say, okay, for €40, I will accept this risk. But let's say I'm going to sell a Maserati Quattroporte, and I think this isn't much money. I want a little more security. What I can say, well, I'll wait 6 blocks, because with every block that is created and stacked on top of it, the probability that it will not be the block that will be accepted by the rest of the world will be smaller. And after 6 blocks, it's pretty safe to say it's okay. Blocks, by the way, on average are found 1 in 10 minutes. So this will take an hour, and so I can wait an hour looking at the car together with the person who is buying it or having a coffee. And we're both happy at the end. So now, why am I going to create blocks? Because I will need to spend CPU time on it, and CPUs tend to use electricity, and electricity tends not to be free. So when I'm going to brute force hashes to find the block, I actually have to pay for it. So why am I going to do this? Well, that's because of the Coinbase. And the Coinbase is the first transaction in the list of transactions included in the block. And it's 25 Bitcoin at the moment. For every transaction, there is one simple rule, and it says that the money you're spending is at least the amount of the money that you're using from yourself is at least the amount of money you're spending to some other people. So you cannot spend more than you have. Except for the first transaction in a block, there doesn't need to be spent any money, it doesn't need to exist. And you can just put 20 Bitcoin in any address you like. So I'll choose my own address, which means that if I'm going to brute force hashes to find blocks, and I do find a block, I can assign 25 Bitcoin to myself, and that's my reward for finding blocks and helping the network be secure. This 25 Bitcoin is not fixed. It's in a period of 4 years, and after 4 years it's halved. So it was 50 Bitcoin at first, so there's a rise in here. Then last December we came to this limit, and now it's 25 Bitcoin, and in 4 years it will be 12 and a half, etc., etc. So you will at the end come close to 21 million Bitcoins being in existence, and there will never be more Bitcoins than 21 million, which is a way to make sure that it is sufficiently rare for it to have value. So this is called mining. And as long as there are still no questions, I'm going on with what if you want to buy Bitcoins, how can you hold them? You need software for it. One of the first applications that was created to hold software is the Bitcoin wallet. It's written in Qt. What you actually see in here is a balance and a list of recent transactions, and you can send coins and receive coins. It's it's not a difficult application. What you here see, by the way, is a balance and an unconfirmed balance. And what this application does is when you receive a transaction, it shows as balance, but not until it has been anchored in the block and 6 more blocks have been created will it show up as confirmed, because then you're pretty sure that the money will not go to someone else anymore. Another client is multi-bit. There was one feature I told about that's when you receive money from different people, you can create a different address for each transaction. So you have a couple of addresses, but let's say you have received 10 bitcoins from one person and 12 bitcoins for someone else, and you need to pay 22 bitcoins. What you now want to do is combine the bitcoins from 2 addresses, and you can, because the information is public, someone can analyze, hey, you've created a transaction using these 2 addresses, so both addresses belong to you. And in that way you can do an analysis and find more addresses that belong to one person. What multi-bit does is it creates a set of separate wallets, and it will ensure that a transaction is never created combining money from addresses that are belonging to different wallets. So in this case, there is a Softpedia test wallet and there is a Softpedia wallet, and any Bitcoin received in Softpedia wallet is never mixed with an address from Softpedia test wallet. Another feature you see in here is a QR code, and that's a rather easy way to send Bitcoin. This just contains the Bitcoin address, which is stored in here. So you can use, for example, your Android phone, make a picture of the QR code, and it already knows the address, and you only need to fill in the amount of Bitcoin you want to send. And that's quite an easy way to send money. Another interesting client is Electrum, and Electrum has a different approach. Instead of generating new addresses for every transaction, which are created randomly, what it does is use a deterministic algorithm to create key pairs, which means that you have one seed, and with this seed you can generate all the addresses and generate all the private keys. So there's only one seed you need to back up, which is quite easy if you're using Bitcoin on multiple systems. If you install it on one laptop and you install Electrum on another laptop or on your phone, and you give it the same seed, it will have access to the same Bitcoins. The danger of this, of course, is if you lose the seed or someone steals it, it can steal all your Bitcoins from all the addresses. It's the downside. As I said, you can send it to an Android phone. This is the screenshot of the Android wallet. Here you also see your Bitcoin address, a balance, and a QR code containing the address. Another way to hold Bitcoins is to keep it in a wallet that is hosted in the cloud. One website where you can do it is Easy Wallet. They will manage for you everything that has to do with cryptography, with managing keys, keeping them secure. What you have is login credentials to access your wallet. The same way like internet banking works. Your bank currently makes sure all the technicalities of intercommunicating with other banks and transferring money is done, and you just give it an order to send money to someone. Another one is Strongcoin. I've never used this one. Another one is Bitstamp, and Bitstamp does something more than only holding Bitcoins. You can send Bitcoins to a Bitstamp account, and you can send US dollars to an account. And then in the market you can create buy and sell orders, which are matched to sell and buy orders of other people, so you can trade US dollars for Bitcoin. Another market where you can do this is Mt. Gox, which is at the moment the biggest. They claim they have 80% of all Bitcoin trade taking place on this website. And they also accept euros, which is quite interesting. This talk is one talk I've given in the Netherlands too. So in the Netherlands there are 2 other ways to buy Bitcoins using Ideal, which is a payment method for instant payments in the Netherlands, like SoFort banking in Germany. One website where you can do it is Wemax Trading. It was just a regular web shop, and they put in a new product, Bitcoin, and you buy and they send it to you. And another one is Bitonic. I don't know if there are any Dutch people in this room. 1, okay, 2, cool. I like the Bitonic people. They're doing really interesting stuff, and you'll probably hear more from them about Bitcoin and Bitonic. So this was actually my talk. If there are any questions, just shoot.
When about 20 years all bitcoins are distributed, how will the blocks be generated, or what's the incentive to generate the blocks?
Yeah. So the question is, when all bitcoins have been generated and distributed, why would someone still keep mining? Because as we've shown in the chart, your coin base will go lower. Well, there's one thing I haven't explained yet. As I said, a transaction, you must spend some money of yourself, and you can create an output to someone else, which is at most the money you have spent. So let's say you spend 10 Bitcoin, you can send it to someone at most 10 Bitcoin, but you can send 9.9, for example. So what then happens is there's 0.1 Bitcoin get lost, but the miner who finds the block can claim this 0.1 Bitcoin and put it in the Coinbase. So in this case, 25.1 Bitcoin you can earn as a miner. Now in the future, the Coinbase, the new Bitcoin value will be less. So let's say it will be 0.6 Bitcoin or so. Then what you can do as a miner is you can say, hey, okay, I will only accept transactions that contain a fee, let's call it a fee, of at least this amount. And if all miners in the world are going to do it, then sending a transaction with a lower fee will not allow your transaction to show up in any block. So everybody is going to pay a small fee to be shown up in the blockchain. The nice thing about Bitcoin is that this is a consensus network. Different miners can keep a different policy. So it would be very possible that in some years you can say, I'll put 0.1 Bitcoin on to make it appear in the next block. But for other transactions, I'm okay if it takes a day or 2 days. I'll put a much lower fee and wait until someone with a more relaxed policy picks it up. Quite probably the cost will tend to go towards what is okay for covering all costs and making a small profit, because otherwise all the miners will start mining and getting the profit. So it's a nice way of keeping the fee in place. Any other questions?
Yeah. When I compare this to PGP, for example, has a web of trust.
Mm-hmm.
Does Bitcoin have something similar? And a second question, what methods are Bitcoin addresses tied to a person? For example, in PGP, you tie it to an email address and a name.
Yeah.
How does that work in Bitcoin?
Okay, so the first question is, in PGP you have a web of trust. Basically, in the core network in Bitcoin, you don't need trust in individual persons. You need to trust that the world is not colliding against you, or actually the majority of miners is not colliding against you. So at that level, there is no web of trust. However, there is an over-the-counter exchange system where people on the internet can find each other to exchange Bitcoin for other currencies, or actually also for products or discount coupons. You find some things like that. And they have created a web of trust system also based on PGP for authentication, which allows you to rate other persons. So let's say we do a transaction and you send me Bitcoin and then I send you the euros. Now you can say, okay, I'll rate Mark because he actually did send me the money he promised. And that way you can find out as a new trader, like, okay, this person has been rated by someone else, so probably he's okay to trade with. The other question was about PGP and...
Yeah, well, in what way is Bitcoin address tied to an identity? Can it be
Yes. Yeah, in what way is a Bitcoin address tied to an identity? The Bitcoin address I created and I've published is tied to me because everybody can see on the internet. I'm using it in my signature on the Bitcoin forum, for example. But you can create a new address just by generating a key pair, and then it's tied to no one in particular. So yes, you can be anonymous in that way, as long as you make sure that when you receive money from someone, where you spend it, if you're combining it with, for example, your public address, then people can analyze and see, okay, you have created a transaction with two digital signatures, one for this address and one for that, so probably you're the same person, and then you're blowing your cover. So yes, you can stay anonymous, but you really need to know how it works and take precautions. Any more questions? Okay. Then I think we're finished. I'll be here for well, some time. If someone maybe wants to buy some bitcoins with cash, a small amount, so I don't have much on my phone, we can do a transaction here. Any questions you can also still ask afterwards. Thank you.